Let me walk you through the Beer-Lambert attenuation tool. Now, Beer-Lambert attenuation is the physical law that describes how light changes color as it moves through a medium, like, for example, water in this case. So the Beer-Lambert attenuation law is actually the math, like the engine that this tool uses. But before we get to that, I'll just quickly show you the script that I've set up here. It's very simple. It's just a little render that I set up in Blender just for as an example, just with some free to use assets. And then it just goes through a little bit of color grading to make this neutral. And this tool works best with neutral light as an input because all of the coloration is getting done by the Beer-Lambert law. And then here we got a light that we'll talk about in a second, an actual light, and then you just have an image for the background. So that's what the script is. So let's go through the little tool. So the first thing you'll notice is you've got inputs. All you really need for this is a depth pass. If you have a position pass and a camera, it's more accurate, it's better, but you don't strictly need it. And then the first thing you need to do is set your world scale. That's basically just describing what unit your 3D program uses. In my case, this is set to meters, so I don't have to change anything. If you use, for example, centimeters, you can set this to 0.01. If you use feet, 0.3048, I think it is. Actually, you can see it right there, 0.3048. That is that's the conversion from feet to meters. But whatever your units are, you'll set that here. Then probably the most important knobs in the tool are the attenuation coefficients. And those are describing how much light there's left after 1 meter of attenuation at 1 atmospheric pressure. It's a technical term for what this is, but really it describes how your image looks, the color of the light as it gets attenuated. And there's a little useful graph here that actually uses a tool by Sapir Martin called X waveform, which is just a way to render a waveform, which is really cool. It uses a Blink script, but here I'm just using it to visualize how the light attenuates per channel. So you'll see that the red will follow first, much faster than the green, and the blue even slower. And then this is actually why the ocean is blue, because of this. So if we go down into the ocean, there's an ocean depth slider here, which we can go deeper down in the ocean with. So you'll see that the light becomes, of course, bluer and darker. And in this case, it goes actually really blue, and it's because this the way these coefficients are. If you wanted less blue, which in this case, of course, you would just reduce the amount of blue that there's actually left after a meter, and it will go less like OTT. Like that. So I'm going to just turn off this graph for now, and then we'll talk about these colors. Now, if you look at underwater photography, a lot of times what you see is a nice gradation where the objects in the front are more neutral, and then it slowly goes through green and then into the blue in the background. And that's because the underwater photographer has set their white balance. In the end, the white balance underwater works actually a little bit different than above the surface because we don't have to deal with attenuation above the water. So it's a little bit of a different way of thinking. There's a compositor, you have to kind of get used to that actually. But there is a automatic white balance here, which we can look at now. So if we set the white balance, you'll notice that the foreground now becomes a bit greener. Not quite neutral yet. It's because we set your white balance actually on subject distance because the colors change with depth underwater. So I'm just going to change this just by eye. And of course, you see that if you adjust it too much, it goes red, which actually that happens in real life as well. But I'm just going to set this down. So now with this, you can see, if I export this actually up a little bit, you can see the foreground has these neutral colors. Then it goes through those greens into the blue in the background, and that, again, it's because of the way the different wavelengths attenuate at different depths. I don't actually recommend you use this. What I recommend you do is actually put a grade node underneath. This will just give you more control. So in this case, to get some of those foreground colors back, you need to set your red channel actually very aggressively, just because at 10 meters depth, which is what we are at here, there's actually almost no red light left at all. So if you do want it, you have to set this very high. And actually, what happens in real life is you would actually have a onboard light, which we'll talk about in a second, to get some of those red colors there if you want that. And then maybe I just reduce the blue a little bit as well, just so we get a little makeshift white balance. And actually, I'm going to set the exposure in that node as well, so we can see that. Boom. Okay, so there's also a simulate water pressure button here, and this is just a very, to be honest, hand wavy way to add some water pressure, because in real life, as you go down into the water pressure increases because of all the water above, and that means that the water molecules are actually closer together, which means the attenuation, there's more attenuation, of course, and that is what it simulates. So you can see that when it is off, water in the back is not as attenuated as it technically should be. Therefore, you can put that on, which usually is better. Sometimes you'll have a shot where you have to break the physics a little bit just so you can see what's going on in the back, and then you can turn that off to help with that, among other things. So that's the basic of it. There's also included in this tool, there's atmospheric effect. Actually, let me hang the camera in the position on this, because we have it, because why not? And actually that reveals that my red channel is too boosted up there. So we talk about that. So actually, before we talk about the atmospheric effects, I'll talk quickly about the onboard lighting. So here we have a light basically that simulates a light that is connected to the camera, which happens a lot in underwater photography. And here I'm just shuffling that into a channel called onboard and then copying it into the B-spline. And here I'm just plussing it up. So I'm just adding that light here. Now, if you look at the Beer-Lambert attenuation node, you'll see that that light from the onboard camera is as attenuated as the rest of the image. And the way the attenuation is calculated is from the surface to the object and not from the object to the camera. When technically this light will only have to be attenuated from the light source to the object and then from the object back to the camera. So we have to actually handle that differently. There's an option in the tool here under underwater light sources to set your onboard lighting source right here. So I'm going to set this to onboard and then turn that on, and you'll see that it becomes more neutral right there. And that's because now the attenuation only is calculated from the light to the object to the camera. So just the math is a little bit different to make it work. Now, if we look at the white balanced version of this, you'll notice that it becomes very red. And that's actually something that happens in real life too. I have an example of that here. This is a video called How to Get the Color Right When Filming Underwater from a channel called Behind the Mask. This is actually a really good video for reference for this kind of thing. And here you'll see they have a white balanced camera underwater with a neutral onboard light. And you'll see that it becomes very aggressively red. So what underwater photographers do is they add a filter, a blue filter to the light to filter out some of those red wavelengths, so that when you white balance it, that light looks neutral. So that would look like that. Right? So we can do the same thing in our in Nuke, just by grading that light and reducing the amount of red in that light until it looks like what we need. That is how you would handle onboard light in this tool. And also we get the same thing for bioluminescence. That's basically for any on any on-screen light source where the attenuation should be only from the object itself to the camera, but it works the same. So that's what that is. I'm going to turn this back off so we can talk about the atmospheric effects, which is basically haze and diffusion. It has this built in just so you have all that stuff in one place. And actually also use the attenuation, for example, for the haze. So I'm going to turn on the haze, and it probably looks a bit crazy, and it does. So the first thing we can do is tell the tool how much attenuation the haze should have. So right now this is set to 5. If I increase this, you'll notice that it becomes darker and bluer, which is very useful. Also, if your camera goes lower, the color will change with it. And then we got here the max visibility knob. This just tells the tool after how much distance. So in this case, after 10 meters, the haze is completely opaque. So you won't see through it after 10 meters. So I'm just gonna push this back a little bit, and you'll see more of the background appear. And there's also a haze fall off here that just is basically an exponential curve that if you want more haze in the front or in the back, you can adjust it like that. So that haze, there's also an additional input here called haze color. And that is mostly to create some shape into your haze. So for example, if you are close to the surface and you have a bright sun above, then you expect the haze around the sun to be brighter. So in this case, I'm just going to add a ramp to just show you. Put the haze color in right there. And then I can just shape the haze a little bit. So rather than a constant color, you get like a gradation there. You can also use the gradient tools here. I find using the haze color input gives you just easier control of that. And there's also a haze tint here if you want to change the color of your haze. Instead of using the haze generation values here, if you want to just fine tune it, you can do that. You can do that there. So that's the haze, and there's also a diffusion, which is a depth-based diffusion. If I turn it on, you can see. And I can again push that back a little bit. So the haze also has a fall-off option here. So I can make this fall off so that the haze is more in the back, and then I can. So that's the haze I'm using. I'm talking about the diffusion here, the diffusion fall off. You can push that back so that the diffusion is more in the background, and then also I can blend this a little bit back here. And of course, you would spend more time making this look good. I'm not going to do that right now. And I also recommend actually adding a overall diffusion on top of everything just to blend everything in a bit. And then I'm just going to mix that back a little bit like that. So that just helps making this look underwater. Of course, you don't have to use that. You can just build your own stuff on top of the attenuation. That works fine. This is just helps blending everything in, and it's nice to have everything inside of the tool. So that is Beer-Lambert attenuation. I should also mention there is a deep version called Deep Beer-Lambert attenuation. What else? And this is exactly the same tool with exactly the same features. The only difference is it uses your deep values rather than a depth pass to create the depth information, and it works properly with semi-transparent edges. So, for example, motion blur edges look a lot better through this through the deep than through the depth. Of course, it is a bit slower, but it will get you a better result for that. So that's deep attenuation. I've been having a lot of fun with this tool and hoping you find it useful too.